Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we're going to talk about classifying quadrilaterals in the coordinate plane. The two things I do want you to know before we go any further are these two statements. The slopes of parallel lines are equal. The slopes of perpendicular lines are opposite reciprocals. For example, -2 and +1/2, +4/3 and -3/4. These two statements are pretty important, especially if you're trying to classify quadrilaterals in the coordinate plane. Now, to classify a quadrilateral in the coordinate plane, find the slopes of all sides of a quadrilateral. Compare the slopes. If necessary, find the slopes of the diagonals. If necessary, use the distance formula to find the lengths of the side. Now, this is very important. The slopes can tell you if pairs of opposite sides are parallel and pairs of consecutive sides are perpendicular, meaning they form a right angle. So without further ado, let's look at some examples. Let's say you are to classify quadrilateral ABCD if its vertices are -5, 4, 3, 4, 3, 1, and -5, 1. All right, so what we're going to do, we're going to find the slopes of the sides. So we have the slope of segment AB. All right, so this is 4 minus 4 over 3 minus -5. 4 minus 4 is 0. 3 minus -5 is 8. And 0 divided by 8 is 0. So the slope of segment AB is 0. Next, we got the slope of segment BC. This is 1 minus 4 over 3 minus 3. 1 minus 4 is -3. 3 minus 3 is 0. And this is undefined because we cannot have a 0 in the denominator. The slope of segment CD. All right, so this is 1 minus 1 over -5 minus 3. 1 minus 1 is 0. -5 minus 3 is -8. And 0 divided by -8 is 0. Next, we have the slope of segment AD. So that's going to be 1 minus 4 over -5 minus -5. 1 minus 4 is -3. -5 minus -5 is 0. And that's going to be undefined. So now that we found the slopes of the sides, let's compare the slope of AB to the slope of CD. They are equal. That means that segment AB and segment CD are parallel. the slope of BC and the slope of AD are equal. This means that segment BC is parallel to segment AD. So now we know that the opposite sides are parallel. We know so far we have a parallelogram. All right, next we're going to look at the consecutive sides. The slope of AB is 0 and the slope of BC is undefined. Now when a line has a slope of 0, that means it's horizontal. If the slope is undefined, that means it is vertical. Therefore, we know segment AB is perpendicular to segment BC. And for the same reason, segment BC is perpendicular to segment CD. Segment CD is perpendicular to segment AD. And segment AB is perpendicular to segment AD. So now we know we have right angles. Therefore, it is a rectangle. But now the question is, do we have a rectangle or do we have a square? How could we tell that we have a square instead of a rectangle? Well, we know that the diagonals of a square are perpendicular. Therefore, we need to find the slopes of the diagonals. So we have the slope of segment AC. And this is 1 minus 4 over 3 minus negative 5. 1 minus 4 is negative 3. 3 minus negative 5 is 8. And next, we'll find the slope of segment BD. And we know this is 1 minus 4 over negative 5 minus 3. 1 minus 4 is negative 3. Negative 5 minus 3 is negative 8, which gives you positive 3/8. So as you can see, the slope of segment AC and the slope of segment BD are not opposite reciprocals, meaning they are not perpendicular. They don't make a right angle. Therefore, quadrilateral ABCD is a rectangle. So now, let's look at the next example. Let's say you are to classify quadrilateral ABCD if its vertices are negative 7, 1, negative 1, 4, 5, 1, and negative 1, 2. So let's go ahead and find the slopes of the sides. So the slope of segment AB is 4 minus 1 over negative 1 minus negative 7. 4 minus 1 is 3. 1 minus negative 7 is 6, which is 1/2. We have the slope of segment BC, and this is 1 minus 4 over 5 minus negative 1. So this is negative 3 over 6, which is negative 1/2. The slope of segment CD, all right, this is negative 2 minus 1 over negative 1 minus 5. Negative 2 minus 1 is negative 3. Negative 1 minus 5 is negative 6, which is positive 1/2. Next, we have the slope of segment AD. And this is negative 2 minus 1 over negative 7 minus, excuse me, let me go back. Negative 1 minus negative 7. So this is negative 3 over 6, which is negative 1/2. So let's see what we got. Well, the slope of AB and the slope of CD are equal. Therefore, segment AB and segment CD are parallel. The slope of segment BC and the slope of segment AD are equal. That means segment BC is parallel to segment AD. So we got the two pairs of opposite sides being parallel. We have a parallelogram. So now let's look at the consecutive sides. Well, the slopes of segment AB and the slope of segment BC are not opposite reciprocals. The slope of segment BC and the slope of segment CD are not opposite reciprocals. The slope of segment CD and the slope of segment AD are not opposite reciprocals. And the slope of segment AB and the slope of segment AD are not opposite reciprocals. There are no right angles. Therefore, it could not be a rectangle. So now we gotta see if this is a rhombus. The diagonals of a rhombus are perpendicular. So let's find the slopes of the diagonals. So we have the slope of segment AC, which is 1 minus 1 over 5 minus negative 7. 1 minus 1 is 0. 5 minus negative 7 is 12. And 0 divided by 12 is 0. All right, next we have the slope of segment BD. All right, let's see. We have negative 2 minus 4 over negative 1 minus negative 1. Negative 2 minus 4 is negative 6. Negative 1 minus negative 1 is 0. And this is undefined. So now, the slope of segment AC is 0, meaning that it is horizontal. Whereas the slope of segment BC is undefined, meaning that the line segment is vertical. Therefore, segment AC is perpendicular to segment BD. And therefore, this is a rhombus. So again, when we find the slopes, we're comparing the slopes of opposite sides, and we're comparing slopes of consecutive sides. And also, we ended up comparing the slopes of the diagonals. So let's do one more example. Let's say you are to classify quadrilateral ABCD if its vertices are -6, 1, -1, 6, 3, 4, and 1, 0. So let's go ahead and find the slope of segment AB. This is 6 minus 1 over -1 minus -6. 6 minus 1 is 5. -1 minus -6 is 5. Therefore, the slope of segment AB is 1. Next, we're going to find the slope of segment BC. This is 4 minus 6 over 3 minus -1. 4 minus 6 is -2, and 3 minus -1 is 4. And -2 over 4 is -1/2. Next, we have the slope of segment CD. So this is 0 minus 4 over 1 minus 3. 0 minus 4 is -4. 1 minus 3 is -2. And that gives you +2. And the slope of segment AD, this is 0 minus 1 over 1 minus -6. So 0 minus 1 is -1. 1 minus -6 is 7. So if we compare the slopes of AB and the slope of segment CD, they are not equal. Therefore, segment AB and segment CD are not parallel. The slope of segment BC and the slope of segment AD are not equal. Therefore, they're not parallel. So we don't have a parallelogram. And since neither pair of opposite sides are parallel, we don't have a trapezoid either. So the possible quadrilateral we can have is a kite. But let's make sure it is. And to do that, we're going to use the distance formula. To find the length of segment AB. So this is the square root of -6 minus -1 plus -6 minus 1 squared. So this is -5 squared plus 5 squared, which will give you 25 plus 25, which is the square root of 50. Now, we're not going to worry about simplifying the square roots. We're trying to see if segment AB and segment BC are congruent, and segment CD and segment AD are congruent. So now let's find the length of segment BC. So let's see, this is 3 minus -1 squared plus 4 minus 6 squared. 3 minus 1 is 4. 4 minus 6 is -2. 4 squared is 16. -2 squared is 4. 16 plus 4 is 20. So the length of segment BC is the square root of 20. Next, let's find the length of segment CD. So this is 1 minus 3 squared plus 0 minus 4 squared. 1 minus 3 is -2. 0 minus 4 is -4. -2 squared is 4. -4 squared is 16. 4 plus 16 is 20. Therefore, the length of segment CD is the square root of 20. Therefore, what we got is segment BC is congruent to segment CD. So now let's find the length of segment AD. All right, so this is 1 minus -6 squared plus 0 minus 1 squared. One minus -6 is 7. 0 minus 1 is -1. 7 squared is 49. 1 squared is 1. And 49 plus 1 is the square root of 50. So therefore, the length of segment AD is the square root of 50. Therefore, segment AB is congruent to segment AD. Therefore, we have a kite. So as you can see, mainly we use the slopes and compare them to see which sides are parallel and which sides are perpendicular. And when we find out which sides are parallel and perpendicular, and sometimes we check the diagonals to see if they're perpendicular, then you can see what quadrilateral it actually is. I hope that you have a wonderful and blessed day.